All right, today we want to learn about how to fill in the unit circle, and this is an extremely important lesson, and it's going to really set the foundation for the rest of all that we do in trigonometry. So let's just kind of jump in. What you see on the top right hand part of your screen is what's called the unit circle, and basically all this is a circle that has different angles, 30 degrees, 45 degrees, 120 degrees, various different angles in a circle of 360 degrees. And for each one of these special angles, we are going to find the sine and cosine values of these angles. All right, so a few things to start off first and foremost. For each angle, they have a cosine and a sine. The cosine of the angle, all right, so the cosine of theta is going to be your x-coordinate, and your sine of theta is going to be the y-coordinate. And the way I remember this is alphabetical order. All right, you see that the C is before S, just like X is before Y. So if you get confused, just go back to that and you can say, okay, well, C for cosine comes before S for sine in the alphabet, so X also comes before Y. All right, so when you're thinking of the cosine value, I want you to think of the X coordinate. Now, this whole unit circle can be derived by, once again, memorizing two special right triangles. All right, the first is going to be a 30, 60, well, we'll do 45, 45, 90. So we have a 45 degree angle there, a 45 degree angle there, and a 90. All right, the other special right triangle that we've been talking about is a 30, 60, 90. All right, and we'll call that 30, call that 60, and we'll call that 90. All right, so these are the two right triangles that you're going to use to develop and build the entire unit circle. So once again, we said that that is 1, and that is 1, and that is root 2. And these are the ratios of the sides. This is 1, this is root 3, this is 2. I'm going to simplify this for you. The last thing I want you to do is to memorize the unit circle. I don't want you to do that. If you can memorize these two triangles, okay, I'll put some stars on these because these are important, then you can get any angle in the unit circle that we ask you to get. For instance, let's go ahead and do the first quadrant only, and if you can do the first quadrant, you can memorize the entire unit, or excuse me, you can actually fill out the entire unit circle. So in the first quadrant, all right, you have several angles here. You have 0, you have 30, you have 45, you have 60, and you have 90. And I think you can see that from the unit circle. All right, first thing we want to learn is that the unit circle has a radius of 1 unit. That's why we call it the unit circle, 1. All right, so if this is your origin, 0, 0, then take a wild guess what the x and y coordinates are for 0 degrees. Well, once again, what is the x? What is the cosine? The cosine is the x. So we know for 0 degrees, it's simply going to have coordinates of 1, 0, right? Because you have to go to the right 1 unit and up 0. Because once again, we're going to call this the origin. This is going to be 0, 0 right here. All right, so if that's 0, 0, you have to go right 1 unit, 1, 0. So the cosine is the x value, and the sine is the y. So maybe I will put a C right there for cosine, and an S for sine right there. All right, so now let's do 30. All right, so if we can remember this, so ka Toa. That's going to help us out quite a bit. All right, so let's go ahead and use this triangle right there. And let's see if we can figure out the cosine of 30. Cosine of 30 is going to be my adjacent over the hypotenuse. Well, the adjacent is root 3, and the hypotenuse is 2. So now we know that the cosine of 30 is root 3 over 2. All right, so now let's do the sine of 30. So we are focusing in on, keep this in mind, focusing in on this angle right there, 30 degrees. And we're going to use the sine, which is the opposite over the hypotenuse. So the opposite is the angle I can draw an arrow across from. So opposite is 1, hypotenuse is 2. So that's going to make the sine 1/2. All right? And then 45. So now we need to switch gears, and we need to use this triangle right here. All right, so now we're going to use that triangle because it has the 45, 45, 90. So cosine is going to be adjacent over your hypotenuse. So I'm going to circle the adjacent side, and your hypotenuse is going to be root 2. So once again, what is that going to be? 1 over root 2. Now, we normally don't write it that way. We normally get the root off of the bottom. So if you multiply top and bottom by root 2 and root 2, you end up getting root 2 over 2. And that is going to be the cosine value for 45. So root 2 over 2. All right, and you can see it's going to be the same for sine because the sides are still 1, 1, root 2. So the sine is going to also be root 2 over 2. All right, now 60. All right, 60, I'm going to use a red marker for that, and we're going to focus in on this angle 60 right here in the corner of this triangle. So 60 degrees is going to be, we're going to do the cosine first. Cosine is going to be ka, adjacent. So let me circle the adjacent side. There it is. That is the side that's adjacent to 60 or next to 60. That's going to be 1. Hypotenuse is 2. So therefore, the cosine of 60 is going to be 1/2. And now we're going to do the sine of 60. All right, so the sine of 60 is going to be opposite over hypotenuse. So let me draw an arrow for you. Opposite of 60. There it is, root 3. What's the hypotenuse? 2. So what is the sine of 60? It's going to be root 3 over 2. Hey, did you notice something? That the sine and cosine values of 30 is switched from the sine and cosine values of 60. All right? Because it's the same triangle. So using the same sides is going to be swapped. All right, so now we're going to get 90 degrees. And I'll use a red arrow for that one. 90 is north. So when you think of 90, think of North Pole. All right, so take a wild guess what the coordinates of that's going to be. If the radius is 1 unit and this is the origin, 0, 0, well, then it's simply going to be 0, 1. 0, 1. All right, and that's going to be the cosine and sine values for 90. All right, so we've got the entire first quadrant filled out. Now, let me give you this tip, and then I want you to fill out the rest of the unit circle sine and cosine values. You can use symmetry, all right? Let me draw an arrow, all right? Let me draw an arrow here. Oops, hold on. All right, we draw an arrow all the way across there. So let's just say that this angle is going to be 150 here. All right, and it's going to be 150 because if you notice that this first angle is rotated 30 degrees above the x-axis, So if you rotate 30 degrees on the other side above the x-axis, that's going to be 180 minus 30, which gets you to 150. So if you were trying to find, let's say, the cosine of 150 and the sine of 150, then you would simply use the cosine and sine values of 30, but notice with 150 you're going left and up instead of right and up. So which one would have to be negative? The x-coordinate would have to be negative. So all you would simply do is take the sine and cosine values of 30 and you would make the cosine value negative. So that would be negative root 3 over 2. And this would still be going up, so this would be 1/2. All right? And you will do that all the way around the unit circle. All right? And that's what I want you to do before you go to the next slide. I want you to go all the way around the unit circle and fill in all of the sine and cosine values and the angles in degrees for each angle. All right, I trust that you have the unit circle filled out, all the cosine and sine values for all the major angles, and also the angles in degrees all the way around. All right, and now what we want to focus on is converting all of these main angles into radians. All right, and there's going to be some easy ways to pretty much kind of do this here. Let's just start with 30 degrees. You've seen several times that the conversion is pi radians. All right, pi radians. Let me write that in here. Pi radians is equal to 180 degrees. All right, so if we think about what 30 degrees is, so if we convert that, 30 degrees, and we're going to multiply that times 180 degrees. Oops, well, same thing. But to make it easy for you, let me just spell out the word degrees. All right, 180 degrees and pi radians. And we see that the degrees cancel, so we end up getting 30 pi over 180, which reduces to pi over 6, because 30 goes into 186 times. Now, you can go through that exercise, or you can just think now, and this is what I want you to do. You can just think of pi as, quote, 180 over 6, which is going to give you 30. All right? So, what would, let me just see if we can just go through a couple examples. What would 2 pi over 3 equal? Well, it would be 2 times 180 over 3. So, that would be 180 over 3 is 60, right? Times 2. So 120. All right? And you'll start to just come up with pretty easy ways. What if I gave you 3 pi over 4? Well, it's going to be 3 times 180 over 4. 180 over 4 is 45, and 3 times 45 is 135 degrees. All right, so this is how you're going to start to convert these all the way across. All right, so you should be able to get the first quadrant in there, 45 degrees is pi over 4. How do we know that? Because pi is really 180 degrees over 4. 180 over 4 is 45. All right? So now, when you think about 60 degrees, see if you can figure that out. 60 degrees would be pi divided by what? Or 180 divided by what? Well, it's going to be 180 divided by 3. So pi over 3 is going to be 60. Hopefully you're picking this up. Let's do 90. 90 degrees. 90 degrees can be written as or expressed as what? 180 divided by 2. Well, what is 180 in radians? Pi. So that's pi over 2. All right? And now we've got the entire first quadrant filled out. Now, the goal now is to fill out all the other quadrants. And this is what you want to do. Here's the key. You want to find an angle in the first quadrant that you can multiply that angle by to get the other angles. So let me make sure that makes sense to you. Oh, let's say we want to find, we'll say 240 degrees. All right, which by the way is right here. That's 240. How do we know? Because south is 270, and this little wedge right there always represents 30 degrees. These smaller wedges are 15 degrees. Hopefully you figured that out. But so if you do 270 and you go backwards 30, you're at 240. Let's say we want to convert that. All right. Well, 240. Here's how you want to do it. This is the key. 240 is really 4 times 60. And that's what you want to think. Let me circle that. 60 is the first quadrant angle you want to reference. You want to think back. How can I write 240 as some constant times an angle in the first quadrant? Okay, so if I already know that 60 is what? Pi over 3. Okay, I'm circling that. Then what is 240? Oh, that's just 4 pi over 3. What did you do? I just put a 4 in front of it. That's it. 4 pi over 3. All right, let's do another one. Let's say we want to find 315. We want to convert 315 degrees into radians. Well, let's just see if we can think about what angle 315 relates to in the first quadrant. Well, it ends in a 5. 3, 1, 5. So we know it's going to be some sort of multiple of 45. All right? And so we have to figure out what that is. Well, it's going to be 7 times 45. Well, what is 45? Let's go back up to 45. I'm circling that in blue. That's pi over 4. So take a wild guess what 315 is. It's going to be 7 pi over 4. All right? And that is going to be how you convert all the way through the unit circle. Let's do one more. Let's say we have 210 degrees. I'm running out of space here, but 210 degrees. We want to convert that to radians. Well, 210 is right here, all right? And what you're thinking now is, what angle in the first quadrant can I multiply by to get 210? Well, let's just think about this. Well, is it 45? No, because it doesn't end in a 5, so that's probably not going to work. 60? Well, let's think about it. 60 times 2 is 120, times 3 is 180, times 4 is 240. Nope, not 60. Oh, it's 30. 30. How do I know that? Because 3 goes into 21. How many times? 7. So how many times does 30 go into 210? 7 times. So if we already know that 30 is, and let me circle that up here, pi over 6, okay? We already know that 30 is pi over 6. So what is 210? 210 is going to be 7 times 30, or 7 pi over 6. And that is going to be the radian value, all right? And by the way, the radians equivalent you're going to put in these little blanks right here that don't have the degrees symbol. So I'm circling all these for you. All right, this is where you're going to fill in those radian values. All right, so fill all those in, and then we'll go to the next slide. All right, on this slide we want to determine which trig functions are positive and negative in which quadrants. All right, so let's start out with quadrant 1. Well, first of all, let's remind ourselves of something. Once again, the cosine of an angle is equal to the x-coordinate, and the sine of an angle is equal to the y-coordinate. Well, if you think about the first quadrant, what are you doing? To get to any angle or any point in the first quadrant, you are going where? You're going right and up. Well, if you go right, you're going in a positive direction. If you go up, you're going in a positive direction. So, the sine and cosine are both going to be positive. So, plus, plus. All right. Now, what is the tangent? We've talked about that before. Tangent is sine over cosine. Or maybe you're more comfortable with it being y over x. Well, let's think about that. If they're both positive, plus over plus, then the overall number is going to be plus. So, tangent of theta is simply going to be positive as well. All right, now we've got the main three, sine, cosine, tangent. Now the other ones are, remember, just the flip of these. So the secant of theta is equal to what? 1 over the cosine of theta. Well, let's think about that. 1 over a positive number is just going to be positive. And I think you can see that the cosecant is going to have the same situation. That's going to be 1 divided by sine. And if the sine is positive, that's going to be 1 over a positive number, which results in a positive number. And you can see that the cotangent is going to be the same thing. Cotangent of theta is equal to 1 over tangent of theta, which is 1 over a positive number, which is basically going to equal a positive number. So what did we just conclude? All 6 trig functions are positive in the first quadrant. All right? All 6 are positive in the first quadrant. Now, so nothing is negative in the first quadrant. Now, in the second quadrant, which is this quadrant right here, let's think about that. You have to now go left and you have to go up. So, ask yourself, which trig function is going to change now? If I'm not going right, I'm going left. Going left is an x direction. That's an x coordinate. So, which one is going to be negative? The cosine is going to be negative, and you're still going up, so the sine, which is your y value, is going to be positive. All right? So, for the second quadrant, you're going to have a negative cosine value. So, maybe we'll put that over here, and we'll say cosine in the second quadrant is going to be a negative number, and the sine still going up, so that's going to be still positive. And then I want you to fill out the other 4 in each in this second quadrant. And remember that the tangent is the sine over the cosine, and the secant is 1 over cosine and whatnot. So you should now be able to fill in these 4 things. Just list them out. Positive, I want you to list which trig functions are positive, and then negative, which ones are negative in each quadrant. All right, this is the last slide, and all we're going to do here is just practice finding various trig values of any angle on the unit circle. All right. right? So let's just pick some. All right, I'm just going to pick a whole bunch of different examples here. Let's say I am trying to find the secant of 210. Secant of 210. All right? So let's see if we can figure this out. What you want to do for each one of these is you want to draw a reference triangle. So let me write that out. Draw a reference triangle. This is key. All right? I want you to really understand this is what you want to do for each one of these examples. Draw a reference triangle. So what is a reference triangle? It is a 30-60-90 or a 45-45-90 triangle in the proper quadrant. Let's see if we can do this. 210, okay? That is in the third quadrant. So we're going to draw a triangle in the third quadrant. Notice how I drew the triangle. I drew the triangle from the origin out to the angle, and actually 210 is not that far out there. So let me do a little better job at drawing that in. All right, 210 is maybe over there. All right, and I drew it up to the x-axis. Now, if this is 180 degrees flat, think about what the angle that you're rotating, how much further beyond 180 do you have to rotate to get to 210? Well, 210 minus 180 is 30. So therefore, you know that 30 degrees goes right there, which means that's 60 and that is 90. All right? So now that we know 30, 60, 90, it's that triangle, you can fill in the sides. And this is going to be 1, this is going to be root 3, and this is going to be 2. However, which way are we going to get to the third quadrant? You are going left and down. Both negative things. And this is where students will lose points on quizzes and tests. They will forget to make that negative and that negative. All right? So you're going left and down. Now, secant. Secant, once again, is the reciprocal. So let's just say secant is the reciprocal of cosine. And what is cosine? Adjacent over hypotenuse. So what is secant? Hypotenuse over adjacent. So what is the hypotenuse? 2. What is the adjacent? Well, once again, you're saying adjacent to what? Adjacent to 30. Okay, let me just say this. You are always going to use the angle that is connected to the origin. That's called a central angle. So the side that is adjacent to that is negative root 3. So hypotenuse over adjacent, negative root 3. And if you get the root 3 off of the bottom by multiplying top and bottom by root 3, you have a final answer of negative 2 root 3 over 3. And that is the answer to this one. Okay, let's do another one. Oh, let's say we want to find the cosecant of 150. Cosecant of 150. Well, once again, let's draw a triangle. And 150, nope, tell you what, I'm going to switch that. I'm going to make it 120. So we're going to do cosecant of 120. All right, so where's 120? It's in the second quadrant. So we're going to draw a triangle in the second quadrant. And I want you to think now. If this is 180, what do you have to rotate backwards? How many degrees do you have to rotate backwards to get to 120? Oh, 60. So 60 goes there, 30 goes right there, and 90's there. Okay, so now we have the same 30, 60, 90 triangle. Starting to get repetitive. So you're going to fill in. So across from 60 is always the root 3. Across from 30 is 1. across from 90 is 2. However, what do you have to do to get to the second quadrant? You have to go left and up. So this needs to be negative. All right? Now the cosecant, remember that is, let me write it out, that is the reciprocal of the sine. Well, what is the sine? Opposite over hypotenuse. So what is the cosecant? Hypotenuse over opposite. We've already gone over all of this. So the hypotenuse is going to be 2. And the opposite is going to be the opposite of 60, which is root 3. Hey, very similar to the last problem we got. So that's going to be 2 root 3 over 3. And that is going to be your answer there. All right, let's do a few more here. And let's say this time we want to find the tangent of 90 degrees. All right, now notice something. 90, let's just draw this out. So you have 0, you have 90, you have 180, you have 270, and this is also 360. All right? Now, 90 is not in a quadrant. It is on an axis. So, for these, you really just need to memorize the coordinates of all these, right? Coordinates on the unit circle. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. You need to memorize all those. All right, so tangent, once again, you're not going to draw a triangle here. You're going to think tangent is what? Y over x, or sine over cosine. All right, what is the y value of 90? It's 1. What is the cosine of 90? It is the x-coordinate. It is 0. Uh-oh, you cannot divide by 0 in math. So anytime you divide by 0, you're going to get an undefined answer. So this is undefined. And you can check all of these on your calculator. All right, let's do another one. Let's say we will do the cotangent of 330 degrees. All right, let's see what that is. I'm just making these up here. Cotangent of 330. So what quadrant is that going to be in? That's going to be in the 4th quadrant. So we're going to draw a triangle in the 4th quadrant. And let's think about this. If this is 360, then what do you have to rotate backwards to get to 330? That's going to be 30 degrees. So 30 is going to go there, and 90 is going to be there, and 60 is going to be right there. We're going to fill out this same triangle. So across from 30 is 1, across from 60 is root 3, across from 90 is 2. However, you're going down, so you need to make the 1 negative. And the cotangent, well, let's think about this. Tangent is what? TOA, opposite over adjacent. So the cotangent is adjacent over opposite. All right, so adjacent is going to be root 3. Let me circle that. Root 3. And your opposite is going to be negative 1. So when you divide those, you're going to get root 3 over negative 1, which is just negative root 3. And that is the answer to the cotangent of 330. And you can do this exercise all the way around the unit circle. So you should be now able to find all 6 trig functions, if asked, for any angle on the unit circle.